Hello everyone, welcome to Math Side Trips, a channel for math teachers, students, coaches, trainers, and enthusiasts. Thank you for sparing time and effort to visit this channel. Many of the topics that have been discussed and will be discussed in this channel are those that are not usually taken up in mainstream classroom instruction. We hope that you will find in this channel something new, interesting, or useful. So this is our channel name, Mathematical Side Trips. In this video, discussion will focus on construction of equations in one variable, in particular, equations involving cube roots. I am Napoleon A. Gaking Jr., a math teacher. Okay, so consider the seed equation 3 is equal to the cube root of 20 plus square root of 49. Other possibilities are 3 is equal to the cube root of 21 plus the square root of 36, or 3 is equal to the cube root of 7 plus the square root of 400 inside the cube root sign. 3 is equal to the cube root of 18 plus the square root of 81, again inside the cube root sign. Well, we can also use subtraction. So here 27 is written as 30 minus 3, and we have 3 is equal to the cube root of 30 minus the square root of 9. Now, let x be embedded in seed equation A, in seed equation A only. Then among many possibilities, we have this equation, cube root of 2x plus 6 plus the square root of 8x minus 7 equals 3. Or these other four equations. In letters D and E, the right side, which is 3, is now written as x minus 4 because our embedded solution is x equals 7. So x minus 4, that is 7 minus 4 equals 3. Let's go back. Okay, that one. And after clearing of radical signs, these equations simplify respectively to the following equations. Letter A becomes x squared minus 23x plus 112, which is the product of x minus 7 and x minus 16. Letter B, 4x squared minus 83x plus 385 times x minus 7 times 4x minus 55 equals 0. So again, clearly the embedded solution x equals 7 is there. And so with equation C, you have x squared minus 49 there. And letter D, we have also x equals 7 as the one of the solutions. And letter E, we have also another quadratic equation, 11x squared minus x squared minus 11x plus 28 equals x minus 7 times x minus 4 equals 0. Note that these equations have been formulated using only one seed equation. Since the number of seed equations is limited only by one's imagination, so is the number of equations that one can come up with. Let A, B, C be constants, L of x, K of x be linear expressions, and Q of x, Q sub 1 of x be quadratic expressions. Then the patterns for the desired equations include, but are not limited to, the following. Okay, number 1, A is equal to the cube root of B plus or minus C times the square root of L of x, which is a linear expression involving x. Then we have the second, here in the second radical sign, which is a square root, we have a quadratic expression inside. Here in number 3 pattern, we have inside the cube root sign a linear expression L of x and another linear expression inside the square root, which is inside the cube root. Again, in letter A, now we have two square root signs under or inside the cube root sign. Then pattern number 5, pattern number 6, 7, 8, 9. These patterns have been designed so that after clearing of radical signs, the resulting polynomial equation is either quadratic in x or quadratic in x squared. Patterns that result in a general cubic or quartic polynomial equation after clearing of radical signs can be similarly constructed, but they would be unnecessarily tough for the students. This is all for now. We hope that you have again learned something new from this video. Please click that subscription button if you want to subscribe and hit that notification bell for updates about upcoming videos. God bless.